Hey, we have now moved on to number 5, and we're looking at higher degree polynomials. And with higher degree polynomials, you can get more solutions. So when we see that the degree is 3 here, this means up to 3 solutions. Does that guarantee we're going to get 3 solutions? No. In fact, I took this polynomial, x cubed plus 2x squared plus x, and I threw it into Desmos and discovered that it's only crossing the x-axis at 2 places, at -1 and 0. So that's why we say up to 3. So let's talk about solving. You do not want to start by factoring the trinomial, even though you have 1, 2, 3 equals trinomial terms. Instead, what you want to notice is that all 3 terms contain an x. So what we begin by doing is pulling out that factor of x, which leaves us with x squared plus 2x plus 1 is 0. And now we can factor the trinomial. X squared plus 2x plus 1 factors as x plus 1, x plus 1. And now let's look at our solutions. If I set this equal to 0, I get x equals 0. If we set this equal to 0, we get x equals -1. And the second factor is giving us the same answer. And that's why we only got 2 solutions. Bada boom, bada bing. Let's move along. Taking a look at B, okay, B has a degree of 4, which means we could get up to 4 solutions. Let's see if this is going to happen. Right here, let's change this to a 4 minus a 3x squared plus 2. And sure enough, I see 1, 2, 3, 4 zeros. Okay, -1, 1, and then whatever this number is here. More on that in a second. So this is a trinomial. You're going to factor it like a trinomial. But since it's to the 4th power, we could write this as an x squared and an x squared. I should address that I didn't pull out a greatest common factor like we did on the last problem, and that is because not all of the terms have an x. Okay, so I've got a plus 2 here. I need to make a -3, so I'm going to go -2 minus 1. If you check, this would be -x squared, and -2x squared gives us -3x squared. All right, let's set these equal to 0. X squared minus 2 equals 0 gives us x squared is 2. And when we root both sides, we get that x could be plus or minus the square root of 2. That's where the -1.414 and the positive 1.414 came from. That's the decimal approximation of the square root of 2. Set this one equal to 0. We get that x squared is equal to 1. Take the square root of both sides, we get that x is equal to plus or minus 1. So there are our 4 answers. Now, if you take a look at C, here's another example where we're going to factor and we could get up to 4 solutions. In fact, I'm going to put this into Desmos. It looks like the only number that's changed from here to here is that the positive 2 became a -4. Is that going to do anything to our solutions? Let's see, -4. Oh, sure enough. Now we're only getting 2 answers at -2 and 2. Let's look at why. All right, so we got a factor, just like on the last problem, x squared, x squared. 2 numbers go here. They multiply to -4. They add up to -3. So those would be -4 and plus 1. In the first case, x squared minus 4 is set to 0. X squared equals 4. Square root both sides, and we get that x is equal to plus or minus the square root of 4, which is 2. So those are the 2 solutions that we got on Desmos, right? Right here we had a -2 and a +2. So the question becomes, why isn't this term right here going to provide us with any solutions? And if we set x squared plus 1 equal to 0, first, I can see right now that there's no way that we can get an x that will make this 0. Because if you square x, you get a positive number. And if you add 1 to it, you get an even more positive number, which means that you're never going to get 0. Now, if we subtract 1 from both sides, you get that x squared is equal to negative 1. And right here at the moment when it is time for us to square root, we're only looking for real answers, no imaginary solutions. So the square root of negative 1 is not a real number, okay? Which means that these are out. Your only answers are 2 and negative 2. Moving on to the last one. This is another problem where I see students make the mistake of saying, oh, s to the fifth is equal to s to the third. I'm going to divide both sides by s to the third. And that would give us s squared equals 1. And therefore, if I take the square root of both sides, s would be equal to plus or minus 1. Well, again, that's true. Both of those are solutions. But when we divide by s, we lose solutions. So don't do this. Instead, just like the problem we looked at in, what was that? Number 3, start by subtracting the s cubed. That would leave us with s to the fifth minus s to the third is equal to 0. This time we can factor out not just one s, but we can take 3 of them. So we would get s to the third power. This would be an s squared minus 1. S to the third times s squared gives us s to the fifth. S to the third times 1 gives us s to the third. So if we set this equal to 0, we can see that the only solution is s is 0. If we set this equal to 0, we get s squared is equal to 1. Root both sides, you get that s could be equal to plus or minus 1. So our solutions are 0, 1, and negative 1. All right, I will see you for the conclusion in number 6.